All right, welcome. Today, we're going to tackle something that's an absolute game changer in Python. We're going to learn how to give our programs a memory, how to make them save data, read files, and remember things long after you've closed them down. So think about this. You've run a program, right? Maybe it asks a user for their name, or it calculates some amazing result. But then, you close it, and poof, everything it was holding on to just vanishes into thin air. It's like your program has short-term memory loss. So where does all that data actually go?
Well, the answer is it doesn't have to go anywhere. This is where file handling comes in. It's the skill that lets us give our programs a long-term memory. It's how we let them create, read, and update files right there on your computer so they can pick up right where they left off.
So, how do we do it? How do we get started? Well, it all begins with one single, incredibly powerful function. Let's take a look at the magic key to all of this, the open function.
Think of open as, well, the key that unlocks any file. You just have to give it two pieces of information. First, you tell it which file to unlock, that's the file name, and second, you have to tell it what you plan to do once it's unlocked. We call that second part the mode. Now take a look at how simple this is. In its most basic form, all you really need is the open function and the name of the file you want to work with. But what's actually happening here behind the scenes? What is Python assuming we want to do? Well, when you write a line of code this simple, Python makes a really helpful assumption for you. It assumes you probably just want to read from a simple text file. And you know what? This default is fantastic, because a lot of the time, that's exactly what you're trying to do. But what if reading isn't enough? What if you need to add new info to a file, or maybe just erase everything and start fresh? That's where file modes come into play. They give us very precise control over our action. Here are the four big ones you're going to use all the time. Think of it like a notebook. Using R for read is just for looking at what's already there. A for append is like adding a new note to the very end of the notebook. W for write is like tearing out a page and starting over completely. And X for create? That's like grabbing a brand new empty notebook, but it'll give you an error if a notebook with that name already exists on your shelf. Okay, there's one more layer to this. We have to talk about the fact that not all files are the same. In Python's world, it basically sorts them into two main categories: text files and binary files.
So on one hand, you have text mode, which we note with a T. This is the default, and it's perfect for files that humans can actually read, like .txt files or even your Python code files. Python helps you out by handling all the complicated text encoding stuff automatically. On the other hand, you have binary mode, or B. This is for everything else: images, videos, program files. When you use binary mode, Python doesn't try to interpret anything. It just reads and writes the raw, exact bytes of the file. And that's absolutely crucial for not messing up the data. You can even combine these, like RT for read text or RB for read binary.
All right, that's enough theory for a minute. It's great to know the concepts, but let's see how this all actually works in practice. We're going to look at a couple of quick code examples. So, in this first example, we're opening demofile.txt. Now, notice the mode we're using, RT. But wait a second, didn't we just say that R for read and T for text are the defaults anyway? So why would we bother writing them out? Well, it really comes down to one thing: clarity. Being explicit like this makes your code so much easier for other people, and for you 6 months from now, to understand at a glance. It just removes any guesswork about what your intention was. Okay, now let's switch gears and look at a totally different kind of file, an image. Look closely at the mode we're using here, RB. This is exactly where that distinction between text and binary becomes so important. So using B for binary mode here is completely non-negotiable. If you tried to open an image in text mode, Python would try to interpret all that image data as if it were letters and words, and you just get a corrupted mess. Binary mode ensures you're working with the raw, unaltered data, preserving the file exactly as it is. Now, before you get too excited and start opening files all over the place in your code, let's go over a few essential safety rules. Think of these as best practices that'll make your code way more reliable and prevent it from crashing unexpectedly. Okay, 3 things. First, before you try to read a file, it's a good idea to check if it actually exists. Second, just take a half second to double check that you're using the right mode for the job. And third, and this is a big one, wrap your file operations in something called a try-except block. It's basically telling your code, hey, try to do this file stuff, but if something goes wrong, don't just crash. Instead, do this other thing. It's a super simple way to handle errors, and it will save you so many headaches. So really, when you boil it all down, what you've learned today is how to give your programs a permanent memory. And that is a fundamental step up in your programming journey. It's the difference between a simple script and a real application that can save user settings, load game data, or process huge amounts of information. You now have the key to unlock a whole new dimension in the programs you write. You can create things, store them, and recall them later. So the real question is, with this new power, what are you going to build? Think about all the possibilities this opens up for your next project.